This is the review for the PERA test, which is going to be the first 20 questions of the semester 1 final exam. It is the same test you took at the beginning of the school year. So I have created examples of what look like all the problems on this particular part of the test. They are all topics that have been covered during the semester, and the problems may be a little more difficult than some of the ones on the rest of the final exam. In problem number 1, it said consider the ellipse below. And then it said if the absolute value of L1 plus the absolute value of L2 is equal to 10, then which of the following is an equation for the ellipse? First of all 4 choices are written in the correct format for an equation of an ellipse. So I can't cross any of them off for being an incorrect equation. But how are we going to determine which equation has the correct numbers involved? So something we didn't tell you, the length of L1 plus the length of L2 is going to equal 2a. Remember that a is the distance from the center of the ellipse to one of the vertices. 3, 0 and negative 3, 0, those are the foci. By definition, an ellipse is the set of all points in the plane, the sum of whose distances from 2 fixed points called the foci. These 2 fixed points, remember each one's called a focus, so plural focus is foci. So it doesn't matter what point you choose on the ellipse. If you find the distance from that point to each foci and add them, it will always be the same. As a matter of fact, that length will be 2a. So now, if 2a is 10, then a is 5, which means that the vertices have to be at 5, 0 and negative 5, 0. Since the vertices are on the x-axis, that means that the bigger number needs to be under x. And the center is at 0, 0, so in the equation, x minus 0 squared over a squared plus y minus k squared over b squared equals 1. H and k are 0, and a squared has to be 25, which means that a has to be the correct answer. If you want to prove that b squared is 16, we have this little formula that c squared is a squared minus b squared. Since I know that c is 3 squared is 9, and then you would find out that b squared is equal to 16. So one of the things you could have done is you could have looked at how the ellipse was elongated and the fact that the foci were on the x-axis. That automatically meant that these two could not be the right answer because the bigger number needs to be under x and not y. Number 2, find the equations of the asymptotes for the following hyperbola. We were focusing on only the slopes of the hyperbola of the asymptotes, but not the actual equations of the asymptotes. Well, the equations are actually really easy to find because, first of all, you need to know what the slope is. So the slopes are the diagonals of this box that we form between the hyperbola. To find the slope of the box, well, here's a point on the line. Here's another point on the line. How do you find the slope? It's rise over run. So the slope must be 3 over 2. It's just that there's another line going down from left to right, which is why we use the symbol plus or minus. Since we're writing the equation of the asymptote, you need to know 2 points, or you have to know another point on the line. We can use something called point slope form. Point slope form is our easiest equation of a line. This is the one we tend to use in calculus, which is why I'm using this one. Well, I know a point on both of those slopes. It's this one, because it's the center of the hyperbola, and the center is at negative 3, 2. So one of the equations of one of the asymptotes is y minus 2 is equal to positive 3/2, x plus 3. But the other equation is y minus 2 is equal to negative 3/2, x plus 3. Again, there are two asymptotes, and the slopes are just opposites of each other. And all I had to do was find one other point on the line, and I picked the center because that particular ordered pair is on both asymptotes. Number 3, the semi-major axis has a length 2 square root of 13, and the foci are at -1, 1, and -1, -5. What is the equation of the ellipse? Well, let's start with the equation of ellipse. It's either this one, or it's the one where a squared is under y. And the first thing we should do is figure out how this ellipse is elongated. In order to do that, we're going to draw a little sketch of where the foci are at. So the foci are at -1, 1, and -1, -5. If these are my foci, my ellipse must look like this. So I actually want to use the one where the bigger number is under y squared, because it's elongated vertically. There are 3 things I need to know. I need to know the center, which is going to be my HK. I need to know A, which is the distance from the center to a vertex. And I need to know B, which is from the center to one of the vertices of the minor axis. Well, they told me that the semi-major axis is 2 square root of 13. That means A is 2 square root of 13, because semi means half. That means A squared, which you get when you square this, it's going to be 2 times 13, which is 26. So I know A squared is 26. I can find the center either by counting tick marks on this little picture or by using the midpoint, because the foci are equidistant from the center. Well, I can tell by counting tick marks that my center is going to be here at -1, -2. But if you wanted to use the midpoint formula, you would add the x's, divide by 2, and then add the y's and divide by 2, and you would still get -1, -2. So h is -1, which means this becomes +1, and k is -2, so this becomes +2. The only thing I don't know yet is b squared, but I know that c squared is equal to a squared minus b squared, and I know what c is now. C is the distance from the center to either focus. C is 3. So I get 9 is equal to 26 minus b squared. I'm going to find out that b squared is 17. So now I can erase this and make it 17. Problem number 4, determine the conic section from each equation. There were rules for how you could tell without needing to multiply any of this out or factor it or put it in general form or anything, which type of conic section it was. If both variables have squares, that means an x squared and a y squared, and the coefficient of both of those terms is the same, the conic is a circle. Because D has an x squared and a y squared, and the coefficient of x squared and y squared is the same, it's a circle. If the conic has an x squared and a y squared, but the coefficients are not the same, but they have the same sign, it's an ellipse. A is an ellipse because x squared and y squared is in the equation, but the coefficients are not the same. If the equation has an x squared and a y squared, but the coefficients of x squared and y squared are opposites, one's positive, one's negative, it's a hyperbola. Hyperbola was the equation that had a minus sign between the factors in factored form. And if only one of the two variables is squared, so you either have an x squared or a y squared, it has to be a parabola. In number 5, what words characterize each type of conic section? So there's some specific words that we use for each type of conic section that we would find if we're given an equation and we graph it. The main words that characterize a circle are the center and the radius, because those are the only two things you need to know in order to write the equation or to graph it. In an ellipse, we also need to know where the center is, but we want to know the major and minor vertices. So we want to know the length of the major and minor axis. And the other word we use when dealing with ellipses is foci. There's another word I did not talk about in class that characterizes an ellipse. It's called eccentricity. Only one of the classes asked me about eccentricity. For the regular class. The honors class, we did talk about eccentricity, but it was so long ago you probably don't remember. Eccentricity was how elongated the ellipse was. If the eccentricity, the value of c over a, was close to 1, it's a circle. Actually, let me flip that. Sorry, if it's close to 1, it was very elongated. But if it was close to 0, it was more like a circle. For hyperbolas, we want to know the center, but we also want to know there are only 2 vertices as opposed to an ellipse that has 4 vertices. We want to know the foci, but we also want to know the asymptotes, whether it be the equations of the asymptotes or the slopes of the asymptotes. Hyperbolas also have eccentricity. It tells you how curvy the hyperbola are, because maybe they're really curvy or maybe they're not so curvy. For an ellipse, this is the one that would be close to 1 if it's not very curvy, and then if it's pretty curvy, it'd be close to 0. Parabolas. Instead of calling it a center, we called it the vertex. And parabolas had one focus, not foci. It also had something called the directrix. So these were the key words that went with each type of conic section. The question on the final exam is going to give you a word and say, or it's going to give you a question that says, which word does not describe this type of conic? In number 6, this was a notation for something called the inverse function. So it says, for his services, a private investigator requires $500 retention fee plus $80 per hour. Let X represent the number of hours the investigator spends working on a case. Create a function that relates the cost to the hours, and then write a sentence to represent the meaning of C inverse 1220. So let's start with the original equation. The original equation, C of X, is going to be the $500 retention fee plus $80 an hour, where X represents the hours. So this particular sentence represents the cost of the service as a function of time, or as a function of the number of hours. The inverse of that, what you do is you basically reverse the units of measurement. So the inverse is going to be the number of hours as a function of cost. It basically says if you're charged $1,220, how many hours will you have worked? Now, they didn't ask you to do that, but the way this works is in order to find the equation of the inverse, you solve the equation for the input. Remember, this is the input, this is the output. So you would subtract 500, and then you would divide by 80. And even though this is x equals, this is the equation of the inverse. It's just that that notation does not show up in the actual equation. So now what that says is you would plug in 1,220 into this equation. It would become the input, and that's the cost, and you would be finding the number of hours. So to find the meaning of an inverse of a function, if you know what the original function represents, all you have to do to find the sentence to describe the inverse is to switch the units of measurement. So the original function was cost as a function of the number of hours, so its inverse must have been the number of hours as a function of cost. Number 7, it says given the function f of x is equal to x plus 3 squared minus 1 on the domain x is greater than or equal to negative 2, what is the equation of f inverse of x? Finding the inverse is easy. We're just going to solve the original equation for x and then flip x and y. But we put a restriction on the domain. This is a parabola if you graph it, except it's only going to be part of a parabola. If I only want to look at this for the domain x is greater than or equal to negative 2, then I would start with negative 2 as one of my inputs, and then I'd use negative 1, 0, 1, 2, and maybe that's all I'd use. So when I plug negative 2 into the original equation, I get negative 2 plus 3 is 1, 1 squared is 1, 1 minus 1 is 0. Negative 1 plus 3 is 2, 2 squared is 4, 4 minus 1 is 3. 0 plus 3 is 3, 3 squared is 9, minus 1 is 8. I'm going to run out of space here for a graph in a second. 1 plus 3 is 4, 4 squared is 16, minus 1 is 15, and 2 plus 3 is 5, 5 squared is 25, minus 1 is 24. The reason that's important is because when you graph this, all you're going to see is, negative 2, 0, negative 1, 3, 0, 8. So you're basically only going to see this part of the parabola. You're not going to see this part. What happens when you find the equation of the inverse? Well, the inverse is what you get when you flip x and y. So I'm going to do this in a different color. That means the ordered pairs on my inverse are going to be 0, negative 2, which is here, 3, negative 1, 8, 0, which, like I said, I'm going to run out of space. It'd be over here somewhere, so you're only going to see this part of the graph. An inverse is what you get when you reflect a graph over the line y equals x. Focus on that purple graph for a minute because the domain of it is really important. All right, let's go back to the original equation. We want to find the inverse of it. Well, how about I just flip x and y, and then I solve that equation for y. So I'm going to add 1. Now that I've added 1, now I can square root the other side. And then I can subtract 3. And that's going to be the equation of the inverse. But there's a restriction on the domain. Remember, the inverse is my purple graph. And the domain is that x has to be greater than or equal to 0. So not only do you have to find the right equation, but you have to know what the domain of the new equation is going to be. And the domain is really just the range of the original function. So if you knew that the domain of the original function was x is greater than or equal to -2, and the range of the original function was y was greater than or equal to 0, that range becomes the domain of the inverse. Number 8, given the functions g of x is equal to 2x plus 3 and h of x is x minus 2x squared, find g of h of x and h of g of x. This is called a composition of functions. And what this says is plug h into g. So into g, we're going to plug in h. So then I get 2x minus 4x squared plus 3, and that would be g of h of x. To find h of g of x, we would plug g into h. So in place of each x, we would plug 2x plus 3. In order to simplify this one, I need to do a little bit more work. Like first, I need to square 2x plus 3. When I square 2x plus 3, I get 4x squared plus 12x plus 9. And then I can distribute that -2, and I get -8x squared minus 24x minus 18. And then I can combine my like terms and write it in descending order of powers. It's -8x squared minus 22x minus 15. Number 9, it says given the function g of x is equal to x over x plus 1, evaluate g inverse of 2. So there are two ways of doing this. But the most direct way is to figure out what, well, one way of doing it is, because you want to find g inverse of 2, this is really y, or the output. So you could plug in 2 for the output and solve this equation for x. So you would get 2x plus 2 is equal to x, and then you would get x is equal to -2, because it's really just a proportion. The other way of doing it is to flip x and y, and then solve that equation for y to get the equation of the inverse, and then plug 2 in for the input. So you get x, y plus 1 is equal to y. You get xy plus x is equal to y. I would get my y's on the same side. So I would get xy minus y is equal to -x. And then I would factor out a y, and then divide by x minus 1. And there's the equation of my inverse. And now I would plug in 2 everywhere I see an x, and I would get -2 over 1, which is -2. That was a lot of work when the first way was a lot faster. So if you're asked to find the inverse of some number, this is just your output. Plug it in for the output and solve for the input. The last problem I'm going to do on this video, number 10, find the inverse relation of the set of ordered pairs below. Very easy to find an inverse. The inverse is to just flip the ordered pairs. Don't do anything to the sign of the numbers. Just literally reverse the order. And that would be the set of ordered pairs in the inverse. And we're going to call that part 1 of the PERA review, and I will do the other 10 problems in part 2.